Yo, what's up, everybody? This is Mr. Nixon. Wanted to do a little video to kind of talk about the urinary system in that chapter. First and foremost, I know most teachers would probably tell me this is a bad idea, but I'm gonna do it anyway because I'm a student right now as well. I feel you on the test. I noticed that several of you did well, and then there were some of you who didn't do so hot. Um, and some of you have already reached out to me, and we've already began talking and discussing what to do about that. And if you were one of those people who you did not do that well on that test, and you're like, I need to know what to do, reach out to me, shoot me an email. We can start that way. I know some of you are taking class on campus. If you want to stop by the office, that's cool as well. Um, it was a tough test. I'm not even going to sit here in front. I know some people will blow it off, but I'm not. It was a tough test because it had biochemistry on it and it had physics on it. And it's one of it turned out to be one of the more difficult tests for this class. Is it one of the more difficult tests overall in 211? Not exactly. It all depends on the class. Some people really, really struggle with the urinary system and the reproductive system. Some people really, really struggle with the hormones and the blood. And some people really struggle with the cardiovascular system. And some people absolutely hate the immune system. It all depends. In my face-to-face 211, I put the immune system with the respiratory system. So, some people like that, some people don't, and it's all to everybody's flavor. But I'm thinking that for some of you, you know what grade you want to make in this class, and you're trying to figure out what to do to make sure that you walk out of here successful. And that's what I want to have conversations with you about, to figure out how to right the ship and do what we got to do to get you where you got to go. All right. So, with talking about the urinary system, and that's chapter 24. This last lecture test is not until the end of April, but don't let that time fool you. I'm one of those people where if you give me a lot of time, I'll take a lot of time, which means I'll get a little lazy and I won't start studying until later. That's bad business. I'm not even going to lie to you guys. I did that for my midterm recently. And how some of you felt about this test is how I felt about my midterm. And I just got so busy. I had so much life stuff going on that I didn't get a chance to start studying for it until about 5 days before it. Man, I needed another week to study for that thing. It was painful. So this last lecture test, not the final exam, but just the last lecture test, is over 4 chapters, which is quite a bit. It's going to be 96 questions. I've already made the test. So when I'm talking to you, let's just say I'll be talking to you for the next few weeks with the test questions in mind. Okay, like I'm going to do right now. So some things to think about when you're studying for chapter 24. And I'm going to have to make about 2 or 3 videos for chapter 24 for you guys, because there's a lot of stuff condensed in that chapter. It looks real short when you count the pages, but it's a lot of information. And chapter 24 is kind of like this little hidden lie, because you get in there and you think there's going to be a lot of information about the urinary system as a whole, but then you wind up finding out that you spend most of the time in the chapter in one structure, which is the nephron inside of a kidney. So let's talk about the system a little bit. Let's talk about some terms that you need to be familiar with. Let me kind of do an introduction to kind of warm you up and open you up to the chapter. And then I'll make another video in a couple of days that will kind of talk about some of the images in the textbook. And if I can get Google Plus to kind of work with me right, I'll make a separate video that will actually include the images from the textbook, and I'll talk you through what you actually see. All right. So first and foremost, the urinary system is only 4 organs to it. You got kidneys, ureters, bladder, urethra. That's it. There's no other organs involved. Nothing else that's really going to impact it. Urinary system's kind of just doing its thing. Now, when the urinary system messes up, he affects a lot of other things, which you'll find out as you go through this chapter and as we go along together through these videos. The other crazy thing about the urinary system is that the kidneys are the only ones making urine and affecting the rest of the body. Your ureters, their only job is to transport urine from the kidneys to the bladder. Your bladder's job, store urine. The urethra's job, to void urine, to excrete it from the body. That's it. 3 out of 4 organs of the urinary system don't do squat, but just transport urine and store it. That's it. But the kidneys, that's where all the action happens. And you'll find out that really, to be honest, with all that stuff happening in your kidneys, there's only one structure in your kidneys that's really making urine, and that's a nephron. It's a microscopic tubular structure that is responsible for filtering all the blood in your body. You got over 1 million of these things in one kidney alone. And so if you mess those dudes up, you're just short. I mean, you're going to wind up having all types of complications, disorders, and diseases. So when you look at the kidney, most of it is made of tubes and blood vessels, just transporting blood or transporting the actual urine. The nephrons are located out in the cortex of the kidney. Most of them anyway. 85% of all the nephrons in the kidney are actually located in the cortex. Another 15% is located in the medulla of the cortex. And if you ever have trouble trying to remember where the cortex is and where the medulla is, think of a watermelon. The melon rind is the cortex, and the pulp, the part that you scoop out and that you eat, that is the medulla. The nephrons, these little tubes, they're made up of 3 major parts. There's the glomerulus, there's the tubules, and then there's the collecting tubule. What I want to kind of chat about just a little bit is I want to kind of talk about those main parts and then some words that you're going to constantly see pop up. So, for example, when you start reading about the nephron, you're going to constantly see them talk about filtration, reabsorption, and secretion. Filtration, reabsorption, secretion. I can almost promise you that you're going to see some questions about filtration, reabsorption, and secretion, because filtration is the process that allows you to get fluids and waste products out of the blood and into a nephron. And then the nephron's job is actually to sift through what you just pulled out of the blood and figure out what you want to keep and what you want to throw away. Whatever you want to keep gets reabsorbed out of the nephron and back into the blood. Any extra things that you want to pull out of the blood and put into the nephron gets secreted back into the nephron. And whatever comes out the other end of the nephron is officially called urine. And you throw that away. It's just that simple. The problem exists in the fact that waste products, things that you don't want, are all thrown in the bloodstream. It's kind of like studying London way back in the 1600s and 1700s. You know, they had a problem with the sewage systems. If you go back and look at the history of London, they had a real bad problem with sewage. They hadn't really fully developed their sewage system. So the same water they were washing clothes in and everything was the same water they were throwing all their waste products in. It was a nasty, toxic mess. Your blood, unfortunately, has not come that far along. Your blood is the same way. The nutrients and everything that are priceless to your cells are floating through your blood. But at the same time, the waste products of your blood, like uric acid, lactic acid, urea, ammonia, you throw all that stuff into the blood as well. So all the blood has to do is it has to go to the kidneys to be filtered. It's like the blood goes to the kidneys to go to the bathroom. And the nephrons within the kidneys, what they do is they allow you to be able to extract the waste products from your blood plasma, pull it all out, because all the waste products are dissolved in the water of your blood. So you can't like reach in there and pull it out and just say, okay, all the blood is just going to travel on by, but we're only going to pull out the nasty stuff. No, that stuff is mixed in there. That's like me loaning you a cup of sugar so you can make some sweet tea, and then I show up at your house later that day and say, hey man, can I get a half of that cup back? You're going to say no, because the sugar is dissolved in the water which made your tea. Well, guess what? That's what happens to waste products. They get dissolved in the water in your blood, so you can't just reach in there and pull them out. They have to go to the nephrons so that on a cellular level, your body can actually pick and choose what you want to keep and what you want to throw away. That's the whole reason why we're going through this nephron process and all this busyness. Filtration happens at the beginning of the nephron, and we'll take our time in another video and kind of really break down what filtration is and why glomerular filtration pressure and filtration rate are so important. We'll also talk about reabsorption and what does that look like, and secretion and what does that look like. Because basically reabsorption and secretion is just the cells of that nephron's way of that's the way of those cells in the nephron being able to pick and choose what you want to keep and what you want to throw away. That's why people with high blood sugar have this weird fruity sweet smell to their urine. It's because they got high blood sugar, and sugar is dissolved in the water. So when your blood gets to the nephrons in your kidneys and it starts yanking out water, sugar dissolves in water. So the sugar comes right out with it. It's too much sugar for your nephrons to reabsorb back into the blood. So unfortunately, that sugar rides all the way to the end of the nephrons and ends up in the urine. That's why it gives it that smell. I was going to go somewhere else with that as well, but that's why reabsorption and secretion are so important to help you balance things out. Now, something you need to really keep in mind, because at this point somebody is watching this video and you've said, wait a minute, you pull water out, blah blah blah. I haven't heard him say anything about putting the water back. Well, actually you do. You pull out a lot of water at the nephron, but you put the majority of it back into your blood before the blood ever leaves your kidneys. So you can't feel the kidneys pulling water out of your blood and putting it back, but that's actually what's happening. You may be able to tell that something is pretty jacked up if you're dehydrated, because your body is sitting there trying to figure out, okay, I need a certain amount of water to create diluted urine, but at the same time this person's not drinking water, so we're having to put water back. What do we do? I'm confused. Help me please. I don't want to be transplanted. All right. So when you're moving substances in the kidney, it's important to keep four things in mind. Plasma, as in blood plasma, filtrate, tubular fluid, and then urine. So let's say those four again. Blood plasma, filtrate, tubular fluid, urine. When you have substances like waste products and nutrients all in your blood, they're all dissolved in the water in your blood, and the water or liquid portion of your blood is known as blood plasma. Remember that? That's from way back in chapter 18. So we had blood plasma, which is the liquid portion, and then we have the solid portion, which are formed elements. Well, we're talking about the plasma, the liquid portion, and plasma is like 92% water, and everything's dissolved in that water. So we extract the water from the plasma. Once it enters into the glomerulus, once it enters into the Bowman's capsule, which is the very front end, or the renal corpuscle, or the renal capsule. It's got a lot of names for it. You got to check it out in text. Once it extracts from the glomerulus and into the renal corpuscle, we no longer call it blood plasma. We call it filtrate. It's the same water that was in the blood. It's got the same stuff in it. Well, mostly the same stuff. It doesn't have a lot of your plasma proteins, because some of your plasma proteins are too big to extract. But everything else comes right on out, and we call it filtrate. Once that filtrate enters into the tube portion of your nephrons, we call it tubular fluid. Then we make adjustments to that, And then we decide how much of that do we want to keep, how much of that we want to throw away. Whatever we keep, we put back in the blood. And as the blood leaves the kidneys, it's got all its stuff. The rest of it that ends up on the other end of the nephron itself, we call that urine. And that's what we excrete from our bodies. All right. Now, one last thing I do want to talk about when you're going into the urinary chapter is there are 4 important functions of the urinary system. And if you remember these functions, it will actually help you learn the other stuff. So one function is it helps to regulate blood pressure. Another function is it helps to regulate acid and base balance. Another thing that it does is it helps you to create red blood cells. And then a third thing that it does is it deals with waste removal. So I just told you about how waste removal works. And like I said, we'll do a couple of more videos and we'll talk about the nephron in detail. So it helps you remove waste from your bloodstream. But the other thing is it helps with acid-base manipulation. Anybody remember the pH of your blood? The pH of your blood is anywhere between 7.35 and 7.45, which is slightly basic. So if your blood becomes too basic, your kidneys can make sure that you keep a few hydrogen ions in your blood to bring the pH down. If your blood is too acidic, then the kidneys can make sure that it reabsorbs enough ions, like bicarbonate ions, to bring the pH back up. It is extremely important that you keep the pH of your blood at a consistent and constant range, because if your body becomes too acidic, if it becomes too basic, you see all types of things begin to occur that has not negative side effects and lead to negative disorders and diseases. It also helps with blood pressure, because if you remember, the kidneys can affect how much water you keep in your blood, which directly affects blood volume. And if you can affect blood volume, you can affect blood pressure. So the kidneys have a direct effect on overall blood pressure of the body. Another thing is that the kidneys are responsible for creating a hormone called erythropoietin, which we nickname EPO. EPO targets red bone marrow and causes you to, create red blood cells. So that's important to remember as a function as well. So those are 4 major functions of the kidneys. It's going to help you regulate acid-base levels. It's going to help you create red blood cells by the release of EPO. It's going to help you with waste removal from the blood, and it's going to have a direct effect on blood pressure. So next time we talk, we will get into the nephron itself. Let's try to spend a little time talking about GFR, which is glomerular filtration rate. We want to talk about what happens at each stage within the nephron. Talk to you soon.